So after I did the video about passive crossover design and how you shouldn't use online calculators, I had a couple of interesting comments, and I also showed it on the forums in a couple of cases where people asked about crossover design. And I mentioned, hey, you shouldn't use those calculators or whatever, and I posted the video. They automatically jumped to active crossovers. So anyways, cutting to the chase, in this video, it's kind of a take two to that previous passive crossover video. I want to show you why it doesn't work to just use active crossovers. They also have their problems because all it does is eliminate the impedance issue. You still have the frequency response issue and you still have the phase issue. So today, I'm going to take one of these mini DSPs, which I'm sure most of you are familiar with. I'm going to set this up with a 1500 Hertz crossover just like we did with the active one. So let's program this bad boy and get rolling and see what happens. This is the same speaker I used for the passive crossover design, still waiting for paint. So I don't have an active crossover worked out for this speaker, so I'm just going to go back to the passive and use that as my reference for good design. Here's the crossover all set up and wired up to individual drivers, ready to go. And there's the results. I also measured the woofer and the tweeter output just to give a little more information this time. You can see the results are similar to last time. Fairly level response. Ignore from about 200 Hertz and down. I don't have the resolution there because I'm measuring in my shop. But pretty nice and even all the way up to a big breakup peak in the tweeter around 18,000 Hertz. A little bit of a bump around 1200 kilohertz where I have a bit too much overlap between the drivers possibly. Okay, now I'm going to hook up the active crossover. Go into 4-conductor wire. And I'm using Speakon. I'm using this iNuke amplifier because it has Speakon. And I can use a 4-conductor wire. So it's nice and easy for active speakers. Okay, here I'm going to just program the mini DSP. It's got its own software where I can select the crossover slopes, the position of the crossover, and things like that. And like I said, I'm going to use 1500 Hertz. This way I am duplicating what I did in the last video, but I am using a steeper crossover because most active crossovers are 24 dB per octave crossover. And even if they are adjustable like this one, most people who use active crossovers will use a steeper crossover anyways. And this page, just I can set the level. You may remember we had to adjust the tweeter level. Ugh! It's worse than I thought. It just really is a bad idea to do this, guys. Here is tweeter only. And here is woofer only. Okay, and here's the results. And what I need to point out right away is the red line is actually the line we're interested in. The green line is the woofer, the blue line is the tweeter, and the red line is what we would hear. There's obviously a big dip right in, centered around 1500 Hertz where the crossover is. And this is not unlike what we saw with the passive crossover, except for it's even worse. This is due to phase. I'll explain that in a minute. But basically the drivers are working against each other in this area, and unless you measure this, you would have no idea it's happening other than it may not sound as good as it could. So if you're wondering why this happens, it's because of phase. And I've mentioned in a couple of videos that phase is responsible for this, or it's because of phase that this happens, but I haven't explained it yet. Now I'm going to try to do that now. It's not going to be easy, and I'm not going to cover everything there is to know about phase. But let's start with this. If you have a crossover point at 1500 Hertz, you have a wave in the sound that looks like this. And it goes up and down 1500 times per second. That's 1500 Hertz or 1500 per seconds. Okay? So that's happening. I'm going to spread it out a little longer to make it more visible. That's happening out of the woofer. You got 1,500 times a second. And out of the tweeter, you also have that happening. But what if they're not in phase, if they're not going up and down at the same time, you may have this. I didn't draw that very good because they started to align over here. So, you know, never mind that. But you can see when this one's going up, this one's going down. When this one's going up, this one's going down. So what happens is when they combine together, they actually cancel out completely. This is what it looks like together. Assuming you've backed up far enough away from the drivers, you know, they're over here. And so we're out in the room here, and those wavelengths start to combine together. So here's the woofer output, and here's the tweeter output. And when you add them up, this is the resultant. And the resultant is 0 dB. Now that's if they're perfectly out of phase, and they're not in our speaker. What's happening in our speaker is this. There's the woofer, and here's the tweeter. So you can see they're kind of overlapping a little bit, and the resultant might be something like over here you have a little bit of output, and then down here, and then up here. And so the resultant, sorry, I'm not drawing this very good, but the resultant is, instead of the full, 87 dB that the speaker response should be, it's more like 70. You know, it's pretty soft. This line doesn't go up and down as much as it should, so the amplitude is less. And that's why phase is a killer. These crossovers, they don't consider phase. Back to our woofer and tweeter. If our woofer, again, we're outputting like this, and if our tweeter is coming out late, what we can do is we can add delay. So if the tweeter normally outputs like this and it's late, we can tell it to wait even longer, and eventually it'll line up with the woofer. And then we get the same output together, and we get perfect summation. And that is the toughest thing to get, whether it's an active crossover or passive crossover. So I just wanted to compensate for the phase shift and show you what the resultant looks like. So I quickly programmed some delay into the mini DSP. I didn't work on this very long, so I didn't get it perfect, but here's the result. You can see that now we get pretty good summation through the crossover point, and now we got a pretty respectable looking speaker actually. It still needs some EQ. There's a baffle step issue below about 800 Hertz. It starts sloping down, and the tweeter response is also sloping down as it moves up towards the high frequencies. Now you should be aware the mini DSP is programmable, and I can compensate for phase, I can choose different slopes, and I have a ton of EQ capability. But there are a lot of active crossovers on the market that can't do any of that stuff. And believe me, if they can't compensate for phase in the, by using delay, they're useless. Don't buy them. They're a pointless device. Well, there you have it. The mini DSP is not a fix-all item that will, or any active crossover for that matter. You cannot just plug and play. It doesn't work that way. Even if I adjusted that crossover point up and down, which I didn't have time to do today, I think we'd see the same phase issues we did here. So ultimately, you're better off with a passive crossover that's designed right than this thing done wrong. Please subscribe to my channel. You can do that by clicking right here. And if it interests you and you want to see more of what this channel is about, you can check out this video right here, which is the previous don't use online crossover calculators video. Catch you later.